Hello, my name is Shadi Hamdan, and for my project I made a model of UC Irvine's Formula Society of Automotive Engineers internal combustion race car. FSAE is a senior design project in a collegiate competition where each university designs and manufactures their own car from scratch and competes in Lincoln, Nebraska. Throughout the entire quarter, being a part of the human interface sub-team, I specialized in steering wheel design and UCI's first ever paddle shifting mechanism. This is the design I came up with for the team, which has a horizontal and vertical inward concavity for maximum rigidity against driver torque. The large holes are for maximum weight saving, with the upper hole being used for the driver's thumb and the bottom holes for his fingers to wrap around. At the top are extruded cuts for an off-the-shelf shift light indicator to be attached to. The steering wheel will be manufactured using a CNC router that we learned about in class, which will cut a female mold into high-density foam that will later be used to do wet carbon fiber layouts. Mated to the back of the steering wheel are paddle shifters and a mechanism designed by myself. At rest, the paddles would be connected via magnets, hence the two cutouts, and will rotate along on an off-the-shelf hinge. When initiated, the magnetic attraction would be released, providing the driver with tactile feedback, and at the end of the paddle's rotation, it will press a button that will activate a linear actuator and provide the quickest possible shift time. The paddles will also be made out of carbon fiber for optimal weight saving. In between the two paddles is a fully functional quick-release system based off another design but modeled and altered by myself for this year's car. This is necessary for FSAE's egress test, which requires the driver to disconnect the steering wheel and get out of the car in under 5 seconds. I began the rest of the design of the car starting from the chassis and working my way through the body using Boss extrude and lofts. I used 3D sketches and weldments while basing the design on UCI's 2019 race car chassis. One of the challenges for this chassis was making sure the 2004 Yamaha R6 engine model would be able to fit snugly into the rear of the car. On the side of the chassis are side pods for better cooling, aerodynamics, and safety. Similar to the steering wheel, the seat provided is a seating design without cushions that will be CNC'd and go through carbon fiber layouts. The front wing and rear wing are a combination of this year's and last year's aero package, once again made out of carbon fiber for the lightest possible weight. The aero components are attached to the chassis using weldments. This project had 18 parts in the assembly but really had over 30 individual parts. I ran a simulation on one of the paddle shifting mechanisms connected to the hinge because of the drivers oftentimes slamming them to shift at the quickest speeds. So at an estimated force, the maximum von Mises stress I got was 2.295 times 10 to the negative 5. This project was very challenging and rigorous for me, but pushed me to my limits of CAD, which will ultimately let me contribute to the team even more.